Hi, everybody. Thanks for joining me today. We're going to go over mental math as it applies to the SAT and the ACT. You may need it even more for the SAT because there are about a third of the questions you cannot use your calculator on them. So the more mental math you're proficient with, the easier that part of the SAT math section is going to go for you. But I found that these tips and tricks work for not only the standardized tests, but you're going to find them useful for the rest of your life, certainly through the rest of your math education in high school and college. So without further ado, let's jump in. The first trick that I want to go over is how to multiply any number that ends in a 5 against itself. Let me give you an example. So if we have the number 15 and we're going to multiply it against itself, that's obviously 15 squared. That's what we're talking about. Now, some of you may know what that is right off the top of your head. You've memorized it. This has come up often enough in math class that you know it's 225. But do you know, say, 35 squared right off the top of your head? Or 45 squared? Or 55 squared? And so on. Well, there's a nice, really fast and easy mental math trick that I can get you started with. So here's how it works. The reason 15 squared is 225 is, well, it's going to end in a 25. And that's not just true for 15 squared, but 35 squared, the answer will end in a 25. So will 45 squared, it'll end in a 25. So our job is to figure out what number or numbers come in front of the 25. 55 squared, you know it's going to end in a 25. So here's the procedure to figure out the number that comes in front of 25. So look at the 1 in 15. Let's multiply it against the number that comes after 1 on the number line, obviously the number 2. So 1 times 2, 225. That's where the answer came from. Let's go to 25 squared. You already know it's going to end in a 25. But you look at the 2 in 25, all right, you look at that number, and you ask yourself, what number comes after 2 on the number line? It's 3. 2 times 3. The answer for 25 squared is 625. 35 squared? Well, 3 times 4 is 12. So you could say the answer is 1225. Now, some math teachers, of course, are sticklers. They're going to be like, 1225? Well, yeah, 1,225. 45 squared? Do you think you got it? 4 times 5 is 20. So we get 2025, 2025. 55 squared? Go for it. I'll wait. That's right, 3025. It's actually a really cool little mental math trick. So let's keep going through. Might as well be complete. Test your times tables as well. What's 65 squared? Can you do it in your head? Because you really should be able to. You know it's going to end in a 25. That's a given. 6 times 7, I hope you know, 4225. 75 squared? Can you beat me before I say the answer? I hope it's automatic. 7 times 8, 5625. 85 squared is going to be 7225. And 95 squared, well, 9 times 10, it still works, 9025. Now, somebody asked me, Mark, what about a number like 105 squared? That is a 3-digit number, not just a 2-digit number like all of these guys. It still works. What's 10 times 11? Well, 110. So you would write down or think 110 followed by a 25, 11,025. So an awesome mental math trick. I wish more of my students already knew it. By the way, one of my students, to her great delight, she was working on an SAT problem, and there was one step in the problem where she was supposed to take the number 1.5 and square it. And she said, Mark, I need to find my calculator. I can't do that in my head. Well, we'd already gone through this. So I'd said, oh, sure you can. You can do this. It's really going to be just like 15 squared. Except, obviously, when we multiply 1.5 times 1.5, we're going to have to be aware that there's a decimal involved, and it actually shows up twice since we're squaring the 1.5. So we're going to take the answer, which is 225, and we're going to shift the decimal 2 spaces to the left. Final answer, 2.25. So this is really useful. I can't tell you how many times, somebody will be like, hold on, let me get my calculator for 7.5 squared. No, you just know it's going to be the same thing as 75 squared, so 7 times 8, 56. 56.25. Shift the decimal 2 spaces, 56.25. All right, so I love that. I hope you found it helpful. Let's move on to the next mental math shortcut. It's when you're multiplying by 11. It's really easy to multiply a 2-digit number times 11. So let me randomly grab a number. Let's do 33 times 11. So what you would do is you would split out the 3 in the 3. You'd create a little space, because what you're going to do is you're going to add the 3 and the 3 together. You're going to sum them, and you're going to pop that number in between where you spread out the 2 digits. Let's try another number. Let's do 52 times 11. We're going to spread out the 5 and the 2. We're going to sum the 5 and the 2 in the number, and we're going to put in a 7, 572. Let's just do a few more so you get the hang of it. How about 24 times 11? Well, spread them out, add the 2 and the 4, 264. Now you might think, oh my God, this is so easy. Well, it is, but something can make it a little bit harder, and I want to go over that right now. What if you have a number like, 82 times 11? Well, you're thinking, I just spread out the 8 and the 2, I add the 8 and the 2, and I put in a 10. Nope. The answer is not going to be 8, 10, 2, 8,102. What's going to happen instead is you are going to carry the 1, and this will become 902. Get it? So it's a little bit harder if when you sum the 2 numbers, it adds up to a 2-digit number, because then you're going to have to carry the 1. You're going to have to increase the number in the hundreds place. Let's try it out with something in the 90s. So here is, how about 90, this will be challenging, 97 times 11. Okay, well, there's a part of us who wants to say it's going to be 9, spread out the 7, add them together, 9, 16, 7. But no, we have to carry. So it's going to become a 10. We're carrying the 1 on the 9. But we still have the 6 from 16, right? The 9 and 7 adds to 16. We still have the 6, and then we still have the 7 that we spread out. So it's going to be 97 times 11 is 1,067. If you don't believe me, you can check it on your calculator. So since it's a little bit harder to work with the ones where they add up to the 2 digits add up to 10 or more, let's just practice that a little bit. So how about if we did 38 times 11? I'll give you a second. Well, I know I'm going to be carrying, so it's going to be a 4, but out of the 11, I leave the 1 behind in the ones place from the number 11, and I still end with an 8. So another mental math shortcut. I don't want the video to get too long, but I want to make sure you know your divisibility tests. Most people know instantly if a number is divisible by 2, right? The number just has to be an even number and is divisible by 2. A lot of people know, well, I'd say almost everybody, know how to tell if a number, just by looking at it, is divisible by 5, right? If it ends in a 5, it's divisible by 5, but also if it ends in 0. So that's great. And of course, people know their divisibility test for 10. any number ending in a 0 is divisible by 10. That's great that people know these three. Tell you though, as an SAT and ACT tutor, I really wish people knew their divisibility tests for three other numbers, for 3, 4, and 9. That's what I would like my students to know. So I usually spend a little time making sure that they can just look at a number, and let me give you such a number. How about the number 234? Okay, is it divisible by 3 just by looking at it? Can you tell? Well, you may know this one. This one's pretty well known, the way to tell. You add together the individual digits of the number. What does it add up to? It adds up to 9, which is a number that's divisible by 3. So the number 234 is divisible by 3. It'll go in evenly. 3 is a factor of 234, and life is good. By the way, it doesn't have to be a 3-digit number. I could give you a really big number, 12,345, and I would add those numbers together to see if it adds up to a multiple of 3. So 1 plus 2 is 3, plus another 3 is 6, plus 4 is 10, plus 5, 15. 15 is divisible by 3, so I know that if I did some long division, it would go in evenly, no remainder. All right, so we've done the divisible by 3 test. That's awesome. But let's go back to the number 234. Is it divisible by 4 just by looking at it? Well, you might think it is because there's a 4 right there in the ones place. That might be helpful. But what you do is you look at the last 2 digits of the number. You don't add them. No adding. But what you do is you just look at it as the 2-digit number 34, and you ask yourself, is 34 divisible by 4? And the answer is no, sorry, it's not. 8 times 4 is 32. 9 times 4 is 36. So we have multiples of 4 at 32 and 36, but it skips right over 34, so that doesn't work. But let's randomly pick another number. This is 900, and let's do 13. We add it up, it adds up to 13. That's not going to work with 4. Excuse me. See, I just showed you one of the errors that you can make unintentionally, but I'll take the opportunity to tell you, a lot of people do confuse the divisible by 3 and the divisible by 4. I almost did. You don't add them individually. You just look at the last 2 digits and you ask yourself, is 13 divisible by 4? And the answer is no, it's not. So how about if we take a look at some other number that hopefully will work? How about 640? Yeah, 40 is divisible by 4. 414, is that divisible by 4? Remember, we're not adding them. We're just looking at the 14. No, that's not divisible by 4, even though there are all kinds of 4s in it. By the way, if a number ends in zeros, like 700, you might not be sure because you're looking at the last 2 digits and saying 0, 0, does 4 divide evenly into that? And the answer is yes, it does. It does. Think about it. 4 goes into 100 25 times. So it's going to go into 200, it's going to go into 300, it's going to go into 400, all the way up to 700. So we have done the divisible by 4 test, and I've made my point a little too graphically, a little unintentionally, that it's easy to confuse 3 and 4. Don't do it. And then 9. Well, that's so easy. It really is the same test as the divisible by 3 test. All you're checking out now is that the number has to be a multiple of 9 when you add up all the digits. So let's do that. We add the 2, we add the 3, we add the 4. Oh yeah, it's 9. It's not only divisible by 3, it's also divisible by 9. So those are the little extra ones. Occasionally a student will ask me, well, hey, what about this little gap in here? 6, 7, and 8. Yes, there are divisibility tests for those, but they're a little more complicated, and I don't personally ever see the opportunity to use them on these tests. And so between their being a little bit more difficult to learn and the lack of opportunity to use them, we've got other fish to fry. Well, this has already been a 16-minute video. Thank you for watching. Practice these. Ask somebody to test you on them, and astound and amaze them with your ability to do some mental math. Thank you very much for watching. This is Mark Schuyler with Schuyler Tutoring, and I'll see you in the next video.